Right guys, as promised, here's a little rundown on how I use TPE. I'm going to jump in and change the date to Monday's supermoon. And now this red pin is our observer's pin. This is where we stand. And the light blue line gives us the position of the moonrise. The dark blue line gives us the position of the moon set. So let's say we want something in the foreground. Maybe we want something silhouetted in front of the moon as the moon rises. We'd want our subject to be somewhere on this moonrise line. So we keep moving our observing position until that's the case. So as an example, let's use Panavan. We would move ourselves into a position where the light blue line crosses Panavan. And in this case, we'd be somewhere on the edge of Fanford. Now the problem with this is that this gives us the position of the moonrise at the horizon, but we're not going to be able to see the horizon because Panavan is in the way. So we need a bit of a more accurate method of calculating our observer's position. In order to do this, we need to know a little bit about how astronomers measure the size and position of things in the sky. Now the sky is modeled as a dome, so we can't use linear dimensions like meters and millimeters. We use angular dimensions like degrees. So the horizon would be 0 degrees as a position, and the zenith, which is directly over your head straight up, would be 90 degrees. So a star at an altitude of 60 degrees would be about 2/3 of the way up. Now you can measure degrees out in the field using nothing but your hands. If you stretch your hand out in front of you, close a fist, your fist will cover 10 degrees of the sky. You can test that theory by stretching your hand out with a closed fist, keeping your arms straight. If you do 1 potato, 2 potato, 3 potato, 4, should take you 9 degrees, 9 potatoes, until your hand is pointing directly up over your head, because 9 potatoes or 9 fists would be 90 degrees. So you'd end up pointing up at the zenith at 90 degrees. Your finger would cover 1.5, maybe 2 degrees, roughly. Now the moon covers an area of 0.5 degrees in the sky, but it's going to be a little bit bigger on Monday. So how is this useful for us? We can use this grey pin here, this target pin, where our subject would be. So we move our target pin to Panavan. Let's just zoom in to make sure we're in the right spot. There you go, it's on Panavan. And once we do that, we get a set of information pop up here relating to the red and grey pins. Now, it tells us the distance between the 2 points is 4.55 kilometers. The difference of elevation of 251 meters, and what's more important to us is this here, the altitude. And it's telling us that if we were to look from the red pin up to Panavan, the tip of Panavan would be 3.14 degrees up from the horizon. So if we stretched our arms out, it'd be roughly 2 fingers worth of space covered by Panavan. So we need the moon to pop up by about 3 degrees before we can even see it behind Panavan. We can use this slider down here, which is the time of day. You can see it's midnight there. Time progresses. Moon sets. There you can see the sun rise with this yellow line here. And you can see the sun's position in the sky, 0.83 degrees. Then the sun begins to set. You see its position decreasing down to 0. And then the moon rises. And we can see the position of the moon here, 1.6 degrees. Let's move time forward a little bit till we're about 3.2, 3.3 will do. 3.2. And you may have noticed that the text changed from grey to black. And that's because it means the moon is now visible. But even though it's visible, it's moved across, so it's no longer behind Panavan. We would have to move our observing position until it's behind Panavan once again. There we go. Now we have another problem where the moon is not visible anymore because we've gone downhill from Fanford, and Panavan is now covering 3.9 degrees. So we'd have to wait for the moon to pop up a little bit higher. 3.9, let's say 4. 4.1's good. We'd have to move our position slightly again, so you just have to keep fine-tuning your position till you get what you want. And there we have, at this position, at 1731, the moon will be just above a silhouette of Panavan and Corn D. Now this is the exact same technique I used to get this shot, Yoga Moon, bit of a shameless plug. And that's all you need to know to get a shot like this, really. How to position yourself and at what time. But there's more you can work out. Let's say you want to make sure your subject is a certain size compared to the moon. Now we already know that the moon is 0.5 degrees in the sky. So let's say we want our subject to be 0.5 degrees, and that's what I was trying to do with this shot here of Carrick-Kenning Castle. My initial plan was to have the moon perfectly fit into the ruins of the castle here. You can see it would have been a pretty good fit as well. But as you can see, this tiny little bit of cloud just lingered in the crucial moments, and it seriously was the only bit of sky in the cloud in the entire sky. So I can't really express how annoying that was. But how did I calculate where to be to get the castle the same size as the moon? There's a relationship between the distance between you and your subject in, let's say, meters, the size, the linear size of your subject, also in meters, and its angular diameter, its apparent angular size. Now we know the moon is 0.5 degrees, so I would want the angle of the castle to also be 0.5 degrees. And if I knew the size of the castle, I could work out how far away to be from it. So I actually went to the castle and measured it with a tape measure. I had plenty of funny looks. Probably should have worn a high-vis jacket or something. But I think it measured to be about 30 meters. And then I used a bit of mathematics to calculate L. If you don't like geometry or trigonometry, you can use an online calculator for angular diameter. You can type in 0.5 for your angle, the size of your object, and it will tell you how far away you need to be. And in my case, I needed to be, I think it was about 4.5 kilometers away from the castle. So I knew the trajectory I needed to be in. I just drew a line until it got to 4.5 kilometers. And it took me to this field where you can just about see the castle through the trees. The lovely farmer there gave me permission to shoot. And as you can see, this cloud here sadly didn't clear in time, so I didn't get the shot that I was after. But I mean, you can't complain because Wales is always cloudy on these astronomical events. So that's about it, really. If you have any questions, please feel free to ask, and let's pray for clear skies this weekend on Monday.